I feel perception by the brain will be more or less a function of a very, very complex mind at work. I feel our brains are taking in much more information than we are conscious of. I feel when our minds register elements in our environment which we have had more experience with, concerns for, have and had interest in, etc. Such information is then more readily taken up by our conscious and subconscious and even may awaken dormant memories and things from our unconscious. I hope this article below from the Watchtower will help everyone understand how complex our minds are. I believe our brains are continually taking in and recalling much information from a young age onward. I feel it is not just the learning, but the unfathomable many other processing of bodily needs and other information which are going on all the time. Such could not have just evolved. The brain, more than a computer. Another superb organ is the human brain. It, together with the rest of the nervous system, is often compared to man-made computers. Of course, computers are constructed by humans and operate according to step-by-step instructions predetermined by human programmers. Yet, many people believe that no intelligence was responsible for wiring and programming the human brain. Although extremely fast, computers handle only one piece of information at a time, whereas the human nervous system processes millions of pieces of information simultaneously. For example, during a stroll in the springtime, you can enjoy the beautiful scenery, listen to the song of birds, and smell the flowers. All these pleasant sensations are transmitted simultaneously to your brain. At the same time, streams of information flow from the sense receptors in your limbs, informing your brain of the moment-to-moment position of each leg and the state of each muscle. Obstacles in the footpath ahead are noticed by your eyes. On the basis of all this information, your brain ensures that each step is taken smoothly. Meanwhile, the lower regions of your brain govern your heartbeat, breathing, and other vital functions. But your brain handles much more. As you walk, you can sing, talk, compare present scenes with past scenes, or make plans for the future. The brain, concludes the body book, is much more than a computer. No computer can decide that it is bored or wasting its talents and should embark on a new way of life. The computer cannot drastically alter its own program. Before it sets out in a new direction, a person with a brain must reprogram it. A computer cannot relax, or daydream, or laugh. It cannot become inspired or creative. It cannot experience consciousness or perceive meaning. It cannot fall in love. The most wonderful brain of all. Animals such as elephants and some large sea creatures have brains larger than that of a human, but in proportion to body size, the human brain is the largest of all. The gorilla, explains Richard Thompson in his book The Brain, is physically larger than a human yet has a brain only 1/4 the size of the human one. The number of different pathways between neurons, nerve cells, in the human brain is astronomical. This is because neurons have so many interconnections. One neuron may connect up with over 100,000 others. The figure of possible connections within our modern brain is as good as infinite, states Anthony Smith in his book The Mind. It is larger than the total number of atomic particles that make up the known universe, says neuroscientist Thompson. But there is something even more remarkable. It is the way this vast network of neurons has been connected that enables humans to think, speak, listen, read, and write. And these things can be done in 2 or more languages. Language is the crucial difference between humans and animals, states Carl Sabag in his book The Living Body. Animal communication is simple by comparison. The difference, admits evolutionist Sabag, is not just a trivial improvement on other animals' abilities to make noises. It is the fundamental property that makes humans human, and it is reflected in major differences in brain structure. The marvelous structure of the human brain has motivated many to make better use of its potential by becoming skilled at some trade, learning to play a musical instrument, mastering another language, or developing whatever talents add joy to life. When you learn a new skill, write Doctors R. and B. Brune in their book The Human Body, you are training your neurons to connect in a new way. The more you use your brain, the more efficient it will become. Made by whom? Could something so highly organized and orderly like the hand, the eye, and the brain have come about by chance? If man is credited with inventing tools, computers, and photographic film, surely someone should be honored for making the more versatile hand, eye, and brain. O Jehovah, the Bible psalmist said, I shall laud you because in a fear-inspiring way I am wonderfully made. Your works are wonderful, as my soul is very well aware. Psalm chapter 139 verses 1-14. Many wonderful functions of the human body take place without our conscious effort. Future issues of this magazine will discuss some of these amazing mechanisms, and also whether aging, sickness, and death can be conquered, so that we can enjoy life forever. Your wonderful neurons. A neuron is a nerve cell with all its processes. Your nervous system contains many types of neurons, which total about 500 billion. Some are sense receptors that send information from different parts of the body to your brain. Neurons in the higher region of your brain function like a video recorder. They can permanently store information that comes from your eyes and ears. Years later you can play back these sights and sounds, along with thoughts and other sensations that no man-made machine can record. Human memory is still a mystery. It has something to do with the way neurons connect. The average brain cell, explains Carl Sabag in his book. The living body links up with about 60,000 others. Indeed, some cells have links with up to 250,000 others. The human brain could hold at least 1,000 times as much information in the pathways connecting its nerve cells as is contained in the largest encyclopedia, say 20 or 30 big volumes. But how does one neuron pass information to another? Creatures with a simple nervous system have many nerve cells that are joined together. In such a case, an electrical impulse crosses the bridge from one neuron to the next. The crossing is called an electrical synapse. It is fast and simple. Strange as it may seem, most neurons in the human body pass messages via a chemical synapse. This slower, more complex method can be illustrated by a train that reaches a river without a bridge and has to be ferried across. When an electrical impulse reaches a chemical synapse, it has to stop because a gap separates the two neurons. Here the signal is ferried across by the transfer of chemicals. Why this complex electrochemical method of passing nerve impulses? Scientists see many advantages in the chemical synapse. It ensures that messages pass one way. Also, it is described as plastic because its function or structure can easily change. Here signals can be modified. Through use, some chemical synapses get stronger while others disappear because of disuse. Learning and memory could not develop in a nervous system that had only electrical synapses, states Richard Thompson in his book The Brain. Science writer Smith explains in his book,